All right, so factoring GCF, difference of cubes, or squares, sorry. Difference of squares, we're also going to be doing the sum of squares. Okay, so both of those. And then basic trinomials. So trinomials where A equals 1. Okay, and I'll get more into that in a second. So factoring all the time, says Buzz Lightyear and Woody. So factors. You've been doing factors forever, and you should have factored last year. And I have talked to your teachers, and they said that you did this over and over and over and over again. So I'm hoping, really, really hoping that this is review, but I will go forward as if we have some gaps in here, okay? So a factor of a number, so like for 6, that factors to 2 times 3. Those are factors of 6. You could also do like 10. Factors of 10 could be 2 and 5. They could also be 1 and 10. Okay, or say you did 100. Factors of 100 could be 1 and 100, 2 and 50. 3 doesn't go into it. 4 goes into it 25 times. 5 goes into it 20 times. 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, 10 does 10 times. So these are all factors of 100. So factors are things that are going to multiply together to give you whatever you want to get. So if we're factoring expressions like x squared plus 4x plus 3, well, if we multiplied x plus 3 and x plus 2 together, that is going to give us x squared plus 4x plus 3. So since these two things broken up multiply together to give us this, that means that these are the factors of x squared plus 4x plus 3. Okay. So now, factoring, called factorizing in the UK, we're not in the UK, but that's okay, is the process of finding factors. And like I just said, they're just two things that multiply together. And you can factor out greatest common factors. So like if we look down here, and I'll do some examples of this, but 2y plus 6, we can see that 2 goes into both of those. So we just pull that out, and we're left with 2 and y plus 3. I'll get into that in just a sec. So this is the factored version. This is the expanded version. Okay. So factoring is the opposite of expanding, where expanding is just really a synonym for multiplying. Okay. Okay, so factoring with GCF. So if we look at this, we want to see like, okay, well, what do we have in common here? What goes into 5x and 30? Well, I think 5 goes into both of those. So then if 5x divided by 5 would just be x, 30y divided by 5 would be 6y, and then whatever you take out has to go on the outside right there. Okay, I like writing this a little bit better, but I did also go through this, so I just divided both by 5, and you get 5 and x plus 6y. Okay, if we do this one, so 9r to the 8th minus 18r squared s minus 24rs squared. So we want to see what goes into all of this. Well, I can see first that they all have this r in common. They have at least one r in common, so I'm going to write that off to the side. And then I need to see what goes into 9, 18, and 24. Well, I know that 9 goes into 18, but does 9 go into 24? No. So then let's see. 9, the only thing that goes into 9 is 3. Does 3 go into 18? Yes. Does 3 go into 24? Also yes. So then my GCF is 3r. So I'm just going to divide all of these by 3r. 9r to the 8th divided by 3r. Well, 9 divided by 3 is 3. R to the 8th divided by r is r to the 7th. 18 divided by 3 is 6, and it's going to be a negative 6 because that's a negative. R squared divided by r is r, and then s just stays because it's not being divided. Well, it is being divided, but it's not being divided by an s, so it doesn't change. And then negative 24 divided by 3 is negative 8. R divided by R cancels, and we're left with that S squared. And then the only thing, whatever we take out, has to go on the outside here. Okay, let's just double check, make sure we get the same thing that we do when I did it before. So 3R to the 7th minus 6R minus 8S squared. I can't figure out how to get this to like stay. So if I write on it, it just goes away. If anyone knows how to do that and you're watching this video, like come talk to me and help me. But so sorry that all my writing always goes away. Let's do this one. I'm not going to write this one out, but 21CD minus 3D. Well, 3 goes into 21, and they both have a D in common, so I'm going to divide both by 3D. 21 divided by 3 is 7, so I'm left with this 7C. And D divided by D cancels. 3D divided by 3D, anything divided by itself. So if you had like 7 divided by 7, that would equal 1, right? If you had 1001 divided by 1001, that would equal 1. If you had x divided by x, it equals 1. It always equals 1. This is a big misconception in math. A lot of students think it equals 0. But think about, like, let's take this one for example. If you had 7 cookies and you had 7 friends, how many cookies would each friend get? Well, you would each get 1 cookie, okay? And then here, since we divided by 3D, that comes onto the outside. Okay? And the whole reason I was doing that equals 1. 3D divided by 3D equals 1. Cool? Last one. So this one, 5x minus 13y. Nothing can be pulled out of that. Like 5 doesn't go into 13. X and y are different variables, so nothing can be pulled out of that. 5 and 13 are both prime numbers. So this is Optimus Prime. I'm just kidding. That was the stupidest. Like, that's like a corny dad joke that you just roll your eyes at, right? If it cannot factor, that means that it is prime. So this is prime. Okay? If it can't factor, just literally all you have to write is prime. You could even write exclamation point if you want. Okay? All right, so working backwards to find the difference of squares. So I want to look at this real quick. If we had x minus 2 and x plus 2, if we were to multiply this, well, that's going to be x squared plus 2x minus 4. And you could use the box. You could use whatever method. I'm assuming you know how to do this. But we can see that 2x and the negative 2x are going to cancel. So I'm left with x squared minus 4. Now, this is called the difference of squares here because this number, x squared, is a perfect square, and 4 is a perfect square. So those are both perfect squares. A perfect square is a number or a variable that you can square root, and when you square root it, you get a whole number out. You're not dealing with decimals, or you're not dealing with leaving stuff in the square root. Okay. So to factor x squared minus 4, remember, factors are just two things that are going to multiply together to give you whatever you want. Well, then that means, Little Dinosaur says exactly what I just said. Well, factoring means breaking it up into parts that multiply to get that. X squared minus 4 is going to factor to x minus 2 and x plus 2. Okay, because the square root of x squared is x. The square root of 4 is 2, and so that's where those numbers come from. So let's do this one. So these should be pretty easy. You're just going to square root both of them. Ignore the subtraction sign, okay? So the square root of 81 equals 9, and the square root of x squared equals x. So then this is going to factor to 9 minus x and 9 plus x. And just put them in whatever order they come out. So since we had the 81 first, the 9s are going to come first. X squared is second, the x's come second. This one, 1 minus 49y squared. Well, square root of 1 is 1. Square root of 49y squared. Well, the square root of 49 is 7. The square root of y squared is y. So that's going to be 1 minus 7y and 1 plus 7y. Okay, this one, 9b minus 100. Again, just factor it. So square root of 9b squared, oh, I just said 9b before, but 9b squared is 3b. The square root of 100 is 10. So that's going to be 3b minus 10 and 3b plus 10. 2n squared minus 72. So notice something here. There is a GCF that we can take out. So 2 can be taken out of 2n squared, and 2 can be taken out of 72. So anytime you can take out a GCF, take it out. I feel like I need to write that down. I wish I would have. So anytime you can take out a GCF, take it out. So anytime you, I've said this 3 times now, you better remember it, can take out a GCF, do it. Okay, write that down. Anytime you can take out a GCF, do it. Okay? Now, the square root of n squared is n. The square root of 36 is 6. The 2 stays on the outside. You don't lose your GCF. Do not lose that GCF. But then we're left with n minus 6, n plus 6. And one thing to note here, I've been doing minus then plus on all of these. You could flip-flop this. This is the same as if you were to say 2n plus 6, n minus 6. Okay, order doesn't matter. Like, same thing here. If you wanted to flip-flop these and you like the plus sign first, that's fine. You can always flip-flop them, okay? Last one, 45q cubed minus 20q. GCF there, I'm thinking it's 5q, so we can take out a 5q, and we're left with 9q squared minus 4. Now, these two things can be square rooted, so that's good for us. So square root of 9q squared is 3q. Square root of 4 is 2. So it's going to be 5q, 3q minus 2, and 3q plus 2. Okay? So now, sum of squares... Dwight says, 1 is the loneliest number. False. Imaginaries are, and they don't even really exist. Okay, first of all, I get people all the time like, why do we even learn imaginary numbers that are imaginary? Well, they're not actually imaginary. They're used for in a lot of concepts, and I didn't put all the concepts they're used for. But imaginary numbers, it's really the square root of -1. So as mathematicians were discovering math and they were trying to find new things, they were trying to take square roots of negative numbers, and they were coming up with like just, I don't know, crazy things. They couldn't figure it out. And so that's where we came up with the complex plane. And they should have called it like a complex number instead of but we ended up getting the imaginary numbers. They do crazy things. So it led to the creation of imaginary and complex numbers, which are used to explain waves, heat, electricity, magnetism. And it's also used by physicists to explain quantum mechanics. Now, I don't understand quantum mechanics, not even a little bit. I even have this book that's like Quantum Mechanics for Dummies because I wanted to, but it's really, really hard for me to understand. But regardless, that's super, super cool that even though I is this number that we deem as imaginary, it's still something, okay? So if we look at this, I want to solve this, so I'm going to set it equal to 0, problem solver, and I'm going to just solve it for x. So if I subtract that 4 over, I get x squared equals -4. But then I can square root both of those. Well, the square root of x is x, and the square root of -4, I can break that up to be square root of -1 and square root of 4, which square root of -1 is I just looked at that over here, and square root of 4 is 2, so that means x equals 2i. That's where the i's come in, okay, and also -2i. So if we were to factor x squared plus 4, it would be x plus 2i and x minus 2i. Now, we're not going to get a ton into imaginary numbers, but I just want to show you real quick that this works because I feel like it helps to see, like, you're not just going to believe me. We need to see it. So x times x is x squared. 2i times x is 2ix. X times -2i is -2ix. And 2i times -2i is -4i squared. And if you remember from last year, I squared equals -1. or even if you looked at this and you were to square both sides, you get that I squared equals negative 1. Because if you square a radical, it just goes away. So then these things are going to cancel out. This is the same as negative 4 times negative 1, which is positive 4. So we do end up with x squared plus 4. Okay. So x squared plus 49, square root both of those, and you get x and 7. So that's really x plus 7i and x minus 7i. 9x squared plus 4, square root both of those, you get 3x and 2. So that's going to be 3x plus 2i and 3x minus 2i. So it's the same as the difference of squares, you just are, there's an I with the second term, okay? Seems easy enough. Okay, last one, factoring basic trinomials. So we've been using the box to multiply. So let's see if we can use the box to factor, to work backwards a little bit. So if we have x plus 2 and x plus 3, if I multiply that out, I get x squared, 2x, 3x, and 6. Adding these two numbers together, you add those two numbers together and you multiply 2 and 3 to get the last number. Okay? And that's just from what we were doing. Like when we pull these out, we're going to add those two together. So we're going to get x squared, 3x plus 2x is 5x. And then we multiply 2 and 3 to get 6. Right? So here, that's what that equals. So if we work backwards to do this, we'd say find two numbers that multiply to give you the last number, and then add to give you the middle number. And let's do an example of that. So 2 times 3 is 6, 2 plus 3 is 5. Let's look at this one. So you can use the box here. I'm going to show you another method also, but n squared and 20. And I'm showing you this because I think some of you might have seen it this way last year. I'm going to show you a couple different ways, but n squared and 20, and these are all just organization tools. So we need to see what are two numbers that are going to multiply to give you 20 and add to give you 9. So multiply to give you the last number and add to give you the middle number. So I just want to look at factors of 20. That's 1 and 20, 2 and 10, 4 and 5. Well, 4 and 5, 4 plus 5 equals 9. So then that's what I'm going to put in here, 4n and 5n. Okay, and then you're just factoring out GCF. So if I look at this right here, between those two, I can factor out an n. Between those two, I can factor out a 5. Between those two, I can factor out an n. And between those two, I can factor out a 4. So this ends up being n4, n5, n plus 5, and n plus 4. Okay. This one, so we're going to see what multiplies to be 24 and adds or subtracts to give you negative 10. So we have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Well, there's two numbers there that will add or subtract to give me negative 10. So I could do 2 minus 12 and I'd get negative 10. And I can do negative 4 minus 6 and I also get negative 10. But they need to multiply to give me a positive 24. Okay, positive 24 and negative 10. Well, the only way I'm going to get a positive with two negatives or two positives. So the only one this could be, 2 minus 12 is negative 10. 2 times negative 12 is negative 24, so that does not work. Sounds good, doesn't work. Negative 4 minus 6 is negative 10. Negative 4 times negative 6 is 24. So that means that one works. It works. It finally works. So that's going to be negative 4a and negative 6a. Between a squared and negative 4, I can pull out an a. Between negative 6a and 24, I can pull out a negative 6. A squared and negative 6, I can pull out a. And negative 4a and 24, I can pull out a negative 4. So that's going to be a minus 6 and a minus 4. Okay. Just a couple more, I promise. So g squared plus g minus 6. So I'm going to use the x here. Now, some of you might have seen the x. This is personally my favorite. It's just an organization, but it helps me organize it. So we want to see what is going to multiply to be negative 6. So the last number goes on top. and the middle goes on bottom. If there's not a number there, we always just assume it's a 1. Okay, so we're seeing what multiplies to be -6 and adds or subtracts to give you 1. So if we look at the factors of 6, that's 1 and 6, 2 and 3. Well, 3 minus 2 will give us 1, and 3 times -2 will give us -6. So this is going to be, 3 and -2. Okay, and then at this point, there will be an additional step later, a different video, but these two numbers right here are basically your factors. So then that's just going to be g plus 3 and g minus 2. Pretty easy, right? Let's do this one real quick. So we want to see what multiplies to be -45 adds to be 4. Well, we have 1 and 45, 3 and 15, 5 and 9. 5 and 9 are the two that are going to, if we do 9 minus 5, that gives us 4. 9 times -5 is -45. Did we just solve the case? Yep. So that's going to be 9 and -5. Okay, and that's c plus 9 and c minus 5. Cool. Sorry I went kind of long. I really, really apologize, but we're all done now. So hopefully you took good notes, and I will hopefully see you in person tomorrow. Okay, bye.